All right, in today's lesson, section 5-2, we're going to solve quadratic equations by graphing. So in standard form, we have y equals ax squared plus bx plus c. We just learned about graphing these, and now we're going to apply it to solving them. So when we're talking about solving, what we're actually mentioning is this is when the answer is y is 0. So essentially, we're looking for where the graph crosses the x-axis. So wherever the parabola crosses the x-axis, those will be our answers. Okay, so there's other names for them known as zeros, solutions. We call them x-intercepts. There's a lot of different names. So you might hear the word roots. That's essentially what we're talking about when we're talking about solving a quadratic. All right, so let's look at some possible answers. So there's some situations that we need to look out for. There are some situations where it will have one real solution. That is when the vertex is on the x-axis itself. Two real solutions when the parabola crosses the x-axis twice, as you can see in the example, and also for when there is no interaction between the parabola and the x-axis. It does not cross at all, so there's just no way to make the parabola itself 0. All right, so let us take a look at some examples. So first we're going to solve x squared plus 6x plus 8. So now let's keep in mind we know how to graph this. So our y-intercept is 8. So I'm going to say, so c is equal to 8. That makes it really easy. I already know that point. So right there. So once I find the vertex, I can use that point to help create some symmetry. So to find the vertex, I got to find x equals negative b, so negative 6, over 2 times 1, which is just 2, which gives me negative 3. So negative 3 is my axis of symmetry, so I'm going to draw that axis of symmetry. All right, so somewhere along here, I got to find the intercept, or the vertex. So I'm going to plug that in, so I get negative 3 squared plus 6 times negative 3 plus 8. So I get 9 plus negative 18 plus 8, so which would give me an answer of negative 1. All right, so my vertex is negative 3, negative 1, so right about there. And then for symmetry, I have 1, 2, 3 spots. So I'm going to go 1, 2, 3 spots this way. All right, so there I have my parabola. So now I'm going to do the best I can to graph this. So I'm going to start down here just so I can start a nice little loop. And if I do that nice little loop nice enough, it looks like my graph intercepts the x-axis at those 2 points right there. All right, so it looks like x equals negative 2 and negative 4. And we can do a quick check. Let's find out. Let's plug them in. So negative 2 squared would give us 4 plus 6 times negative 2, which is negative 12. So we got 4 plus 8, which is 12, plus a negative 12, which is 0. And then for negative 4, we get 16 plus negative 24 plus 8, which again equals 0. So those are my solutions. So x equals negative 2, comma, negative 4. And I'm done. Okay. So once again, solve 8x minus x squared equals 16. Now, with these situations, we do not want them equaling number. Whenever we're solving a quadratic, we want it equal to 0. So I got to get everything off one side to make it equal to 0. So I'm going to move the x squared because I want a positive, and x squared. So if I move everything, well, now I have x squared minus 8x plus 16 is equal to 0. Now 16 I see as c, but that is really high up on my graph. I'm not able to graph it. So I am going to just start with the axis of symmetry. So x is equal to negative 8, positive 8, because negative b, over 2, which just gives me 4. So there we go. So I'm going to go to positive 4 and draw my axis of symmetry here. Alright, so then I'm going to plug that in. So 4 squared minus 8 times 4 plus 16. And that gives me an answer of, let's see, 16 minus 32 plus 16. Well, that just gives me 0. So right there is my, well, we talked about this. It's the vertex. The vertex is actually lying on the axis, so that's most likely my answer. But let's graph just in case. So let's go one number over. So I'm going to plug in, I'm going to make a quick chart. Here we go. I'm going to make a t-chart here. So if I have x and y, I have 4, 0. And then I'm going to put in 3 and see what I get. So if I plug in 3, I get 9 minus 24 plus 16, and that gives me an answer of positive 1. So then using symmetry, I should be able to get the exact same thing on the other side. So here is my parabola, and since it touches the x-axis at 4, my answer is x is equal to 4. And there we go. Let's do one more. And now this one has a little bit of different connotation. Solved by graphing. Sometimes we've come up with an answer that isn't an exact whole number, so it's hard to guess exactly what it is. It could be a random fraction, or it could be the square root of a number. Something really random that you would never guess. So we're just going to talk about adjusting and stating what two integers it's between. So here we can look, well, let's use our c is equal to -1. So we go down to -1. Okay, and now we need our axis of symmetry. So x is equal to -4 over 2 times -1. So I get -2, which just gives me 2. So I'm going to go to 2 and axis of symmetry. Okay, and so now when I'm looking at this, I want to plug that 2 in again. So I get -2 squared plus 4 times 2 minus 1. Okay, and when we plug in 2, we get an answer. Oh, I'm put my parenthesis in the wrong spot there. Sorry about that. So we get -4 plus 8 minus 1, which gives us 3. So we go over 2, up 3. And so now we have some symmetry here. So let's go to 4, -1. And so now I have my parabola. And if I go down, notice it's really awkward. And it looks like my answers are right here. It's between 0 and 1. And then it is also between 3 and 4. All right. So my answers lie somewhere between 0 and 1 and 3 and 4. So that's the problem with graphing, but sometimes that does happen, so we need to be ready for it.